Hello, grade 9th. We will be talking today about representing inequalities. Now, thinking about the word inequality, there's obviously the word equal right smack dab in the middle. Now we see this prefix in. Well, if I talk about a prefix in or un, things like that, we're talking about not as that meaning of that prefix. So inequalities we use when things are not only equal. Okay, so we use an equal sign when things are just only straight up equal. And we use inequalities when things are not just only equal. So when we talk about inequalities, we're talking about things that have more than one solution. They're very helpful when we want to represent more than one solution. And usually that set of solutions, because there are multiple, is a range of values. So there's a starting point in which those values can take on, those solutions can be, and an ending point when those solutions can be. So say, for example, I have between $5 and $10 in my pocket, inclusive, meaning I could actually have 5 and I could actually have 10. All of the possible values I could have in my pocket, there's a starting point of 5 and there's an ending point of 10, and all of those numbers between 5 and 10, that range is my solution set. It's all of the answers that can possibly make my statement true. Okay, now there are a couple of different inequality symbols that we will see. There's 4 of them, and there are these 4 here. And they are, the first one here is less than. And the second one is greater than. When we think of these symbols, I know historically we've only looked at these symbols and putting them in between 2 numbers. So if I had like 2 and 3, I know this symbol goes in between. And if I have 3 and 2, I know I use that other version of the symbol. But when we read symbols in like algebraic statements, we want to read from left to right. And when I'm reading from left to right, I can think of a symbol like this as on the left-hand side, there's kind of one point that makes up that left side. And there's 2 points that make up that right side. And I know that 1 is less than 2, so that symbol represents less than. And then kind of thinking about that in reverse, if I have this symbol, the first side has 2 points that make up that first side. And the second side's only 1 point, and I know that 2 is greater than 1, so this symbol is the greater than 2. So just like we read from left to right, we need to make sure that we're also interpreting those symbols in that same direction. Now in both of these symbols, less than or greater than symbols, the value, that number that we use, is not included as a possible solution. So if I have x is greater than 3, well, yeah, 4 is a possible value for x, 5 is a possible value for x, 28 is a possible value for x, 3.1 is a possible value for x. All of those values for x satisfy the inequality, meaning they make the inequality true. But the value in our statement, specifically 3, is not a possible solution because 3 is not greater than 3. Okay? When we use the other 2 symbols, the ones with the lines underneath, we kind of read them in the same way. So this is still less than, except that line underneath also means or equal to. And then that other symbol would then represent greater than or equal to. Now, these symbols allow that value in our statement to be included as the possible solution. So instead, if I said x is greater than or equal to 3, 4 would still work, 5 would still work, 19 would still work as values for x that satisfy our inequality. But this time, with that or equal to portion underneath, that means that I could also have the value of 3 as a possible solution because 3 is equal to 3, and because we're including values that are equal to 3, then that value is included. Okay, let's talk about writing inequalities. Inequalities will always have a proper form, and that proper form, I should say when here, that proper form is always going to have the variable come first. So x is greater than 2 would be in proper form. Y is less than or equal to 17 would be in proper form. Things that would not be in proper form is if I had an inequality that the variable did not come first. So 12 is less than a, or -1 is greater than or equal to b. So we always want to make sure that we write our inequalities with the variable first. Okay, I do want to kind of talk us through how we can kind of flip things. So we know that if I had 3 and 2, I know that 3 is greater than 2. Hopefully you know that as well. Take a couple seconds, write that statement backwards. What if I had 2 and 3? What symbol would go in between? Write it down. Okay, what did you get? Hopefully you got that symbol facing the other direction. Because when I write something backwards, that bigger side of the inequality still has to match that bigger value. And the smaller side of the inequality has to match that smaller value. Now, this is pretty obvious when we have numbers and we could see which one's bigger and which one's smaller. But that same idea applies to values that aren't numbers. So for variables, for example. So if I wanted to rewrite 12 is less than a in that proper form, I would flip my variable to go first and my number to go last. And I would maintain that a had the bigger part of the inequality symbol up here. So a is going to have the exact same larger side of the inequality down here. So if I change the order, I need to change the direction of the symbol. And same idea, if I have -1 is greater than or equal to b, and I flip it, that I need to change the direction of the inequality. Okay, we are going to look through a couple of examples, and we're going to write algebraic statements based on the English expressions and vice versa. So I want you to take a couple of seconds and see if you can try these on your own, and then we'll do them together. So pause the video. And welcome back. So we have the first one saying a number less than or equal to 5. So we use variables to represent unknown numbers. So a number can be x, it could be n, it could be q, it could p, it could be any other letter. And I have less than or equal to 5. The next one says numbers less than 12. So again, we can use any variable to represent my unknown number. And I know those numbers are less than 12. Here, I'm giving the algebraic representation and I want to write the English expression. So my variable could represent a number. So a number, and then I read that symbol, greater than or equal to, and then 4. Okay. Now, we are going to get into how to graph inequalities on a number line. Now, when we graph inequalities on a number line, typically we can see values pretty easily. So if I had x, whether it be greater than or equal to, or less than or equal to, hopefully I could see that that 3 is going to be involved. Now, that 3 is considered one of my endpoints, which means the range of solutions will end at 3, okay? Because whatever that 3 is, that will be a point we cannot cross. Now, on that 3 on my number line, I am going to draw a circle. The type of circle depends on the type of inequality that I have. Now, we kind of saw this in the Desmos activity, but an open circle, one that is not shaded in, will be used to represent the value not being included as part of my solution set, or my solution range. That means that the value of 3, in my example that I've kind of made up here, will not be allowed to be taken on. I will see an open circle when I either use a less than or greater than symbol, because x itself cannot be 3 if it's less than 3. and x itself cannot be 3 if it's greater than 3. So the type of inequality symbol will help dictate the type of circle I use. Same idea, but in the other sense, I use a closed or shaded in circle to represent a value that is included as part of the solution range. So if I use less than or equal to, then I know I can have x be equal to 3 because 3 is a possible value that makes that inequality true. And same idea, if I had greater than or equal to 3, x can equal 3 because it is a value that makes that inequality statement true. So if I have those inequalities, I will use a closed circle. Okay, going back really quick, taking a look at these ones. I want you to tell me either open or closed or open for these 3 inequalities. Write it down. And hopefully you said closed, open, and closed, because this has an or equal to, this has an or equal to, but the one in the middle does not. Okay. So when I take a look at the first inequality from my number line, I am always going to start with my variable and my endpoint, that number where the dot belongs. So I have -3 here, so I'm including -3. Now, my open circle indicates that I'm either going to have a less than or greater than symbol. I am not going to have an or equal to portion at the bottom. Now, I want to know where all the values of x can take place. And I can actually tell based on the line that all the values of x can take place above the -3. Right? I can have -2, I can have -1, I can have 0, 1, 2, 3, 4, 5, 6, 7, etc., and so on. So all of those numbers for x are going to actually be bigger than -3. If you have a hard time trying to figure out, is it greater than or less than, a couple things that can help you. In your mind, you can picture, instead of putting x there, picture one of the numbers in that shaded part of the arrow. So that blue arrow, 4 is one of the numbers along the arrow. And so if I was picturing a 4 instead of an x, I could then be like, okay, I know 4 is bigger than -3, so I'll make sure that I have that greater than symbol. Okay, that's the first one. We're going to do the same thing, kind of going backwards. We're given the inequality, and then we want to draw the number line that kind of represents it. So when I take a look at this, I know I'm going to have a dot at -5, or the circle at -5. I know it's going to be a closed circle because it has an or equal to portion at the bottom. So I'm going to start by drawing a closed circle at -5. Now, I want to find the direction in which my numbers are going to be less than or equal to -5. And again, if you could find a number on the number line that's going to be less than or equal to -5. So let's say -6 is going to be less than -5. That can help me talk about that direction that the arrow is going to be traveling. Right? Because the arrow, that shaded line with the arrow, represents where I can find all of the answers, all of the possible solutions to that inequality. Okay, small little life hack for you. If you always write inequalities in proper form, let's say x is greater than 7, x is less than or equal to 3, x is greater than or equal to -4, x is, I don't know, let's say less than -19. When I look at the number lines here, if I have these in proper form, I can typically draw these number lines quite easily. I know that my point of interest, where I draw my circle, is going to be along the number included in the value. Now, the type of circle is going to depend on the inequality. The ones that do not have an or equal to portion will have an open circle. The ones that do have an or equal to portion will have a closed circle. Now, here's the little life hack I'm teaching you. All of these inequalities, you could picture them like arrowheads, right? This arrow is pointing to the right. My solution region is going to be to the right. This arrow is pointing to the left. My solution region is to the left. This one to the right. Solution region to the right. This one to the left. Solution region to the left. Now, this only works if we are in that proper form, variable and then value. This is another way to help kind of remember which way to go, but of course you want to make sure you understand what values x can be. So if I want x to be greater than 7, I think 8 is greater than 7, so I want my arrow to point in the direction where 8 will be. Okay, now we're going to talk about compound inequalities. Compound inequalities are made when I have more than one simple inequality kind of combined into one statement. Now, there's two ways to combine inequalities. The first way is to have OR statements. OR statements tell us that the values that satisfy work for either one inequality or the other. They won't satisfy both conditions. So say, for example, I want to buy, a soccer ball. Now, I'm okay with paying very, very little money on a soccer ball. Like if it's less than $5, cool, great, I'll have a soccer ball. I know the quality's not going to be good, but when it's so cheap, it's easy to replace. But I also would be willing to pay over $30 for a soccer ball because I know the quality will be good over $30 and I won't have to replace it. So I'm okay with paying less than 5 or more than 30. I am not okay with paying in between those two values because I know I'm still going to have to replace it. And at that price point, it's just not worth it for me to have to replace when it's already relatively more pricey. So if it's less than $5, fine, I will buy it. If it's more than $30, fine, I will buy it. But I will not pay for it if it's in between, more than 5 and less than 30. With that being said, I've just said two inequalities. Now, I can't find a price point that actually meets both conditions, right? Like $35 soccer ball meets that it's more than $30, but it is not less than 5. So they're not actually values that satisfy both inequalities. It's just possible solutions that only satisfy one of them. That's why we say or. It's one or the other. Now, how we graph them is actually quite simple. We graph both of them separately. So if I take a look at this one, I have x is greater than or equal to 5, and I have x is less than or equal to -2, and it's an or situation, which means I'm happy if my values of x are greater than or equal to 5, or if my values of x are less than or equal to -2. And so I'm going to graph those two separately. I'm going to graph the one I've circled in purple first, so I'm going to put a circle on the 5. That circle is going to be closed because it has an or equal to portion. And I am going to point my arrowhead to the right because all of the values greater than 5 are like 6, 7, 8, 9, etc. And that's where they lie. They lie to the right of my endpoint. I'm also going to graph my other one, x is less than or equal to -2. I'm going to put a circle on -2 and I'm going to fill it in and I'm going to close it up because I have that or equal to portion. And I know that my line is going to move to the left because if I want values that are less than -2, well, -3, -4, -5, etc. are all included in those and they belong to the left of that number line. So it's actually quite nice to graph inequalities from or situations because I just do them separately. And I do them separately on the same number line. Which means going from graph back to inequality is also quite simple because I could figure out the inequality that represents this. I could figure out the inequality that represents that. And I can write or in between. So that is what we're going to do. I'd like you to try it on your own and then we will do it together in just a minute. So pause the video. Okay, so hopefully you've paused it. This first one here, I'm going to use x. I have -8 because that's my endpoint. I know my arrow is pointing to the left. Because I am writing it in standard form, my inequality is going to match. I know I'm going to have an or equal to portion because I have a closed circle. Now, my second inequality, I know I am going to use that same variable, and this time my other endpoint is -4. When I take a look at that inequality, I know all of the values bigger than -4 are also included. That's where the arrow is. So I know greater than is going to be included. I do not have an or equal to portion because I have an open circle on that number line. Okay, and those are compound or statements. We have one more set of compound inequality statements, and those are and statements, which means I have two inequalities and both inequalities have to be met. So if I have, again, let's say I have between $5 and $10 inclusive in my pocket, I can't have $28 in my pocket because 28, even though it's greater than 5, it satisfies that part of my inequality. It doesn't satisfy the second condition. And when I have and, I need both to be met. So when we have those two inequalities that both have to be met in an and situation, we actually combine those inequalities to write one mega single inequality. And situations on a graph will also be represented by having no arrows. They have two distinct endpoints, a point at the beginning and a point at the end. And the and situation will represent all of the values in between those 2 points. Okay? When we take a look at these endpoints, we can actually write inequalities kind of separately to begin with or to kind of imagine in our head. But I'm going to talk about how I could write that into one single inequality. So I'm going to start off by splitting them up. You don't have to write this down, but I want you to interpret this. So let's pretend I had this purple inequality and this blue inequality. And I'm going to draw arrows because that's the direction the line extends from each of those endpoints. Now, if I was this purple inequality, I'd have my variable, let's say x. I'd have my endpoint, which is -2. And I know I'm traveling to the number line side that is bigger than -2, because anything to the right on a number line is my bigger numbers. So I know x can be bigger than -2. There is no or equal to portion because that circle is open. It is not filled in. If I were to take a look at this blue inequality, I know I still have that same variable. I know I have the number 1 for my endpoint, and my values, that arrow is extending to the left of my number 1. It's in the smaller side. It's less than. And then I'd have the or equal to portion because I have the closed in circle. Now, this is technically how I can write an and situation as two separate inequalities. But our goal here is actually going to be to combine these into one mega inequality. So I'm going to take this information and I'm going to bring it here and I'm going to talk you through how to make one mega inequality. It's actually quite simple. What we're going to do is we are going to put our information in order from smallest to greatest. So I know the smallest is -2 and the biggest is +1. And I know the value for x that x can be is going to be somewhere in between those. So to write a mega inequality, I'm simply going to write my smallest, my value for x, and my biggest, because I know x has to be between those two values, so I'm going to write it between the smallest and the biggest. Now, when I write it in this order, which is super cool, is I'm always going to have less than symbols, because the smallest is always going to be less than the biggest, which is also true for any chunk of things. My x values are going to be bigger than -2, or -2 is going to be less than x. And it's also true for x being less than +1 here as well. So if we write it in order, we're always going to use less than symbols. The last bit that we do is we just include or equal to lines under our inequalities when the circles are closed. So this one had an open circle, so no or equal to is needed. This one had a closed circle, so I'm going to have an or equal to portion here. Now, this is what our final answer should look like for our and situation, where we write things into a single inequality. What I wanted to point out, or why I made us go through and write two inequalities, is because I wanted to show you that I could see those two inequalities in here, right? X is less than or equal to 1. I can see that in here, no problem. The other one, I still see in here, but I see it written backwards. Instead of saying X is greater than -2, I have -2 is less than X. So we practiced writing inequalities backwards, and we are able to get that same result. So kind of neat. Going from inequality all the way to graph is actually a little bit more simplistic. I know that for these mega inequalities, these and situations, those two numbers represent my endpoints. So I'm going to have a circle at -2 and a circle at 5. I don't want to say that your teacher done goofed a little here, but she forgot to include a 5 on the number line. So instead of doing this, I'm actually going to ask that we change this to a 3. Okay, so we've changed this to a 3. So I now have an endpoint at -2 and an endpoint at 3. Now the one at 3 is going to be a closed circle because I have an or equal to in my inequality. Now, if it's an and situation, those two regions are going to line up. They're going to connect because what it's saying is that my X value is going to be bigger than -2, right? X has to be bigger to the right of -2, and it has to be to the left of 3. So my mega inequalities here will always make one solution region that's connected. All right. That is it. That is all. There is some practice that follows. Please try that practice out. And that is it for today. Have a wonderful day, and I will see you tomorrow. Bye.